this reaction, we're taking some copper chloride solution. It is dissolved in water. It is a bluish solution. Most copper solutions are blue. And we're going to use an electrical current to break this down into copper metal and chlorine gas. In order to do this, we're providing electricity. Electricity is going to make the reaction go. And this is an endothermic reaction because it requires energy. As soon as an electrical current starts being applied to the solution, you can see at one of the electrodes, this one, you start to see a yellowish color. And that yellowish color, it looks kind of green because of the blue color, but it's a yellow gas. That's actually chlorine gas forming. And it's just being formed right around that electrode. And on this one, you can see it getting darker and thicker, and that's actually copper metal forming on there. I just nudged off a bunch of it. If I lift it out, you can see that it has kind of a coppery sort of look to it. Now, I removed the energy source, so the reaction has stopped. It's no longer taking place, but if I add that chemical battery energy to that again, that reaction will proceed, that endothermic process. And one of the things with this reaction is that the chlorine has a very strong bleach sort of smell, which shows evidence that chlorine gas is being produced. So I'm hovering my face over it right now, and I can smell that chlorine gas. In this reaction, you have to wash the electrodes off well, and this copper tends to really stick to the metal, so I have to really be mindful to try and get that copper off of there, but I think some of it has been permanently electroplated on. So this is an endothermic reaction, requires energy. We're taking copper chloride and breaking it down into copper metal, which was the chunks, and chlorine gas, which was that yellow colored, smelly, bleach smelling stuff.